ECVET-compliant AgroInsure curriculum. Training videos. Project AgroInsure. ECVET-compliant training to implement ecologically viable agriculture on industrial surfaces of urban environments. Green roofs for sustainable agriculture. The topics covered include the suitability of different roof types for green roofs, various building types, residential, commercial, industrial, the impact of construction materials on sustainability, and load-bearing capacity analysis using finite element analysis, FEA. The role of industrial protective coatings in preventing structural damage, the optimization of land use through vertical and horizontal farming concepts, the integration of green infrastructure into industrial surfaces, and the compliance and safety regulations for urban agriculture are interrelated important topics. Introduction. Sustainable agriculture roof types, materials, and load capacities analyzed via finite element method. Structural analysis covers seismic performance and durability. Includes waterproofing and protective coatings. Highlights vertical and horizontal farming. Covers green infrastructure, rain gardens, water recycling. Concludes with urban agriculture regulations and safety guidelines. Roof types. The roof, as the topmost part of a building, protects against natural elements like snow, rain, wind, and extreme temperatures while also influencing aesthetics and durability. Roof surfaces are typically sloped to facilitate water drainage, with slope variations depending on climate, roofing materials, and building design. Wood is a common roofing material, though industrial buildings such as factories, garages, and workplaces often utilize reinforced concrete or steel for enhanced strength. Shed roof, a roof with one slope, historically attached to a taller wall. Gable roof, a straightforward design resembling an inverted V, also known as ridged, dual-pitched, peaked, saddle, pack saddle, saddleback, or span roof. Cross-gabled roof, formed by joining two or more gable roof sections, often creating a T or L shape, or more complex configurations. A-frame roof, a steeply angled gable roof forming an A shape. Bonnet roof, a reversed gambrel or mansard roof, with a lower pitch on the bottom portion. Butterfly roof, V-roof, London roof, a V-shaped design resembling an open book, with two sections sloping inward at an obtuse angle. Hidden roof, a specialized roof design in Japanese architecture. Cross-hipped roof, created by intersecting two or more hip roof sections, often in T or L shapes. Sadari roof, a Swedish double hip roof with a short vertical wall and small windows, popular in formal 17th century architecture. Mansard roof, French roof, features a steep lower slope and a shallow upper slope. The steep section may be curved, characteristic of the Second Empire architectural style. Gambrel roof, curb similar to a mansard roof, but sloped in one direction. Bell-cast roof, sprocket, flared a roof with a shallow slope at the eaves transitioning to a steeper slope above. Pavilion roof, a low-pitched hip roof, symmetrical on all sides, often atop square or polygonal floor plans. Pyramid roof, a steep hip roof on square buildings. Tented roof, a polygonal hipped roof with steep slopes converging at a peak. Helm roof, a pyramidal roof with gabled ends, frequently seen on church towers. Spiral roof, a steeply pitched spire with a twisting design. Barrel roof, barrel-arched, cradle, wagon, a rounded roof resembling a tunnel or barrel vault. Catenary roof, an arch design based on a catenary curve. Arched roofs, includes bow, Gothic arch, and ship's bottom roofs, historically called compass roofs. Bell roof, a roof shaped like a bell, compared to bell-cast eaves. Botchka roof, a roof with a distinctive curved, barrel-like profile. Conical roof, also known as a cone roof, featuring a pointed, conical shape. Roof types. Building types. Understanding commercial buildings is essential for professionals in various fields. Entrepreneurs planning to establish a business requiring a physical location need to be familiar with the types of commercial buildings available and how local zoning laws may impact their operations. Real estate professionals should understand the distinctions between residential and commercial properties to better serve their clients. For developers, construction professionals, architects, engineers, and others involved in creating commercial buildings, it's crucial to grasp not only what defines a commercial building but also the laws and codes governing different types of facilities. Additionally, the infrastructure requirements of commercial buildings often differ significantly from those of residential structures. Residential buildings. Residential buildings are designed for individuals to live in, featuring separate residences with self-contained facilities like kitchens and bathrooms. Key types include apartment, a single living unit in a multi-unit structure. Condominium, a multi-unit structure where individual units are privately owned, with shared ownership of common areas. Apartment building, a structure with 3 or more independent living units, each with its own cooking and bathroom facilities. Multi-usage buildings. Commercial buildings. Office buildings, from single-story offices to skyscrapers. Restaurants, standalone or multi-use dining spaces with kitchens. Retail spaces, stores, malls, and boutiques. Hotels, temporary accommodations for business purposes. Warehouses, storage for logistics and retail. Healthcare facilities, revenue-generating hospitals and clinics. Multi-use buildings, mixed use, primarily commercial. Building types. Industrial buildings. Industrial buildings support manufacturing and production activities. Key considerations include planning. Proper planning enhances efficiency, and unplanned projects can reduce productivity and cost. Value factors. Architectural design, use of recycled materials, energy efficiency, and environmental responsibility increase value. Selection criteria. Factors such as climate, location, available materials, and building codes must be considered. Industrial buildings. Selection criteria. Climate, location, availability of materials, material costs, installation expenses, surrounding buildings, building geometry, aesthetic considerations, engineering requirements, functionality, local customs, restrictive covenants, compliance with building codes, materials used for buildings. Reinforced concrete structures. Concrete is a composite material made from aggregates and cement. Hydration binds the aggregates into a solid mass. Non-reinforced concrete has high compressive strength but is weak in tension. Reinforced concrete incorporates steel bars, rebar, to improve tensile strength. Modern techniques include pre-tensioning and post-tensioning to enhance durability. Materials used for buildings. Finite element analysis, FEA. ECVET is a computational method for structural analysis. Divides structures into smaller components, finite elements. Solves a system of equations to assess stresses and deformations. Benefits. Identifies weaknesses. Optimizes design. Ensures realistic material modeling. Discretization of the structure into finite elements. Each element has its own set of equations based on shape, material properties, applied loads, boundary conditions. Elements are connected at nodes. Solves equations simultaneously for the entire structure. Finite element analysis, FEA. Understanding the different types of industrial protective coatings and application methods. Concrete flooring options, epoxy and polyurethane. Standard concrete floors can be enhanced through polishing or industrial coatings. Polishing improves appearance while sealing the surface, reducing issues like dusting and efflorescence caused by concrete's porous nature. Concrete is durable and long-lasting. With proper sealing and maintenance, it can last a lifetime. However, cracks and moisture damage can occur if left untreated. Concrete is low maintenance. Oil and other contaminants can be easily cleaned. In environments with hazardous chemicals, combining concrete with proper drainage systems improves safety. Understanding the different types of industrial protective coatings and application methods. Though not chosen for aesthetics, concrete can be dyed or coated for visual appeal. Refurbishing existing concrete slabs is also an eco-friendly option in many commercial settings. Epoxy flooring. Epoxy is created by mixing resin with a hardener. Even a thin layer strengthens concrete and extends its lifespan. It's dust-resistant, easy to clean, and doesn't retain salt. Available in many colors, epoxy can brighten a space and enhance lighting. It resists heat, chemicals, and damage, with strength up to 10,000 psi. Polyurethane flooring. Polyurethane is ideal for high-traffic and heavy-load areas. Though more expensive than epoxy, it lasts longer and offers better resistance to acids, solvents, and thermal shock. It is also more elastic, providing greater scratch resistance, suitable for spaces like parking structures. Integrating green infrastructure with industrial surfaces. Urbanization and industrialization have caused environmental issues like pollution and biodiversity loss. A solution is integrating green infrastructure into industrial surfaces, which enhances sustainability and resilience. Green infrastructure includes features like green roofs, vertical gardens, permeable pavements, and bioswales that provide benefits like water filtration, temperature regulation, and habitat creation. While initial costs can be high, long-term savings in energy and water offset these expenses. Technological innovations, such as lightweight materials and smart monitoring systems, make green infrastructure more feasible for industrial use. This approach reduces environmental impacts and improves economic and social outcomes, positioning industries as key players in global sustainability efforts. Compliance and safety in urban agriculture on industrial surfaces. Urban agriculture on industrial surfaces, like rooftops and repurposed land, is a sustainable way to address food security and environmental concerns in cities. Successful implementation requires understanding zoning laws, building codes, food safety standards, and environmental regulations. Key safety considerations include structural integrity, worker safety, PPE, fall protection, and public safety, signage, health protocols. Risk management involves assessing structural, environmental, and operational risks with emergency plans and insurance coverage in place. Stakeholder engagement and sustainable design, such as modular green roofs and automated irrigation, are crucial for project success. Continuous monitoring ensures the project adapts to changing conditions, ensuring long-term viability and community benefits. Conclusion: green roofs evaluated different roof types, material selection, and load-bearing capacity for sustainable agriculture. Industrial protective coatings play a crucial role in preventing structural damage and enhancing durability. Vertical and horizontal farming offer innovative solutions for optimizing land use in urban areas. Green infrastructure highlighted ecological applications such as rain gardens and water recycling. Regulations and safety cover the necessary compliance and safety standards for urban agriculture. Green roofs are essential for sustainable, efficient, and safe urban farming. For more information, contact details. Thomas Blum.